and welcome to your first lesson on trigonometry, Introduction to Trig. We are going to talk about the sine function, the cosine function, and the unit circle. This is the beginning of Chapter 9 of our CPM book. Before we start the actual lesson, I wanted to review finding sine and cosine ratios because that skill will be super important. Remember, cosine is equal to the adjacent side of the triangle divided by the hypotenuse. Make sure you start at the angle indicated. I like to work with these triangles by rotating them so that the angle is located along the base of the triangle, because for me it's easier to find the adjacent and hypotenuse using this angle here. Adjacent would be this side 9, hypotenuse 3 root 13. You can see it took some work to finish this problem because 9 divided by 3 root 13 can be reduced. 9 and 3 can both be divided by 3. I now have 3 root 13, and to fully finish this problem, I don't want a square root in the denominator. So I will multiply by a giant 1 of this square root 13. So the top then, I'm multiplying 3 and square root 13 together. I cannot multiply a square root with a regular number, so I will leave it as a product. But the denominator is equal to the square root of 169, which square roots to 13. Example number 2, a sine function. This time I'm given 2 side lengths, and I'm going to rotate the triangle. Remember, sine is opposite over hypotenuse. So with this angle, I need side opposite, which is 5, and then this side had not been labeled, so I needed to find that number. Because this is a right triangle, I can use Pythagorean theorem, and showing the work here, I got 13 for the hypotenuse. So the sine then, again, is opposite over hypotenuse, so 5 over 13. I cannot reduce that, so this would be my answer. So the beginning of the practice that goes along with this lesson would be finding sine and cosine ratios like this. Please leave the answer as a fraction, just like I've shown you here. Moving on. Today's lesson, the new part, is going to be introduced with this ride called the Screamer. You enter the ride right here, and then the ride rotates so fast that you scream, hence the name Screamer. This part of the ride is above ground, and this part of the ride is below ground, making it extra scary, and hence, again, the name Screamer. Please note that your height above the ground will be called a positive number when you're above ground, and a negative number for below ground. Notice there's even water at the bottom to splash through. Ah! When you get back to when you've made one complete rotation, you get back to the beginning, and this ride could go around several times before it stops. But each time, you just rotate through the exact same circular path. That is the idea that we're going to use to help us understand trig. I'm going to actually use this paper. All right, so here's the Screamer ride. Notice that instead of seats, I've now just used angles. Each seat is equally spaced out around the circle, and the difference is 15 degrees between seats. Now, what do I mean by 15 degrees? Let's talk a little bit about how the angle is written. You get on the ride here. Your seat hasn't moved at all, so 0 rotation. As your seat moves, so does the line connecting to your seat. When you get to here, that rotation has been 15 degrees. The 15 degrees is actually located right here between the positive x-axis and the radius that your seat is connected to, or where your seat ends. Because of that, this is called the terminal side of the angle. Starts, finishes, or terminates. There. So the terminal side of the angle. You always write the angle right next to the origin. So if your seat's rotated, I've drawn a circle at 60 degrees. So let's say you rotated to here. Your seat is located right here. When I say 60 degrees, I'm writing it here as a convenient spot to indicate your seat and that it's rotated 60 degrees. What that really means is from the positive x-axis to here. And again, you draw the angle right at the origin. 90 degrees. Notice that the pencil and the positive x-axis make a right angle, hence a rotation of 90 degrees. Notice what happens if you rotate past that. You now have an obtuse angle. You could even rotate all the way to quadrant 3, and the angle again is 210 right here. That means you've rotated from the positive x-axis all the way around to here. So again, you write the angle close to the origin, starting at the positive x-axis, going all the way to where the pencil is, or the terminal side of the angle. That is what I mean when I say a 210 degree angle. For convenience, we're just going to write the angles all the way around. However, I have highlighted in orange one example of an angle so that you could see that for reference. Please note that given this triangle, this is the radius. And you might notice that I've written here 100 feet. What I mean by that is the screamer ride's radius is 100 feet. So when your seat is right up here, you are 100 feet off the ground. When your seat is over here, you are 100 feet away from the y-axis or the origin. So this side of the triangle represents height, and this side of the triangle represents base. This side of the triangle is the hypotenuse and represents the radius of the ride. The rotation is always counterclockwise. We'll talk about that later. And as long as the rotation's counterclockwise, your angles will be listed as positive numbers. And you always enter the ride right here. All right? So, I also want to mention that I have a comment here that says you are below, when your ride gets below the ground, when your seat, I should say, like right here, you have a negative height. I also want to indicate, notice that these 4 seats have been highlighted with a dot. So all 4 of these sites are 1 tick mark above the ground or below the ground. They have all rotated 15 degrees, either before they get to the ground or underground. And so all of them are the same distance from the ground, whatever this height would be. This would be represented as a positive height, and then this would be a negative height. So if this was, say, 26 feet above ground, then this would be 26 feet below ground. And over here, 26 feet above ground, 26 feet below ground.